Mechanical Department of BVM Engineering College has many equipments and setup in which young engineers will be interested. These equipments are having educational value as well as historical value. I am Mahesh Jinjuwadia, retired professor of Mechanical Engineering Department of BVM Engineering College. Today, we want to understand, we want to see, we want to have a look of Parsons reaction turbine. It is a historical device as well as that device has many important features. This is 50 kilowatt Parsons reaction turbine of our laboratory. It is coupled with electrical generator and it is fitted with different instruments. Instruments are such that performance testing of this steam turbine can be carried out. We know that steam turbine runs at higher speed, electrical generator runs at lower speed. So, to reduce rotational speed between steam turbine and generator, reduction gearbox is provided. Again, this setup has many integral equipment. Here, steam condenser is provided and in this condenser, condensation of steam takes place. Inside the condenser, very low pressure. In other words, we can say that very high vacuum is maintained and steam condensation takes place. Steam expands in steam turbine and then it enters in this condenser. Here, for performance testing of steam turbine, there is mechanism for consumption of electrical power generated by generator. Here there is pump driven by electric motor which circulates cooling water continuously inside this condenser and condensation takes place. Again, at many locations of steam turbine, we have to provide lubricating oil and for that purpose, here there is lubricating oil pump which provides oil at higher pressure. During operation, we are maintaining very low pressure inside the condenser and for that purpose, here there is steam ejector, steam jet air ejector which removes air from condenser and it develops very high vacuum inside the condenser. Here, steam is used for that purpose. It means that this equipment replaces vacuum pump and it has many advantages. First main advantage says that this equipment does not have any moving part. Again, steam generated in boiler enters in this steam turbine from supply pipe and then its expansion takes place. In this steam turbine, two main components are there. One is rotor and another is housing. Housing also is known as stator or stationary part. In the rotor, in this turbine, initially at inlet, impulse stage is there where velocity compounding is carried out and downstream to that there are 16 number of reaction stages. Now, impulse stage is provided at inlet for particular reason. If we provide impulse stage at inlet, energy transfer will be having higher efficiency. That is why it is preferred. And in this impulse stage, velocity compounding is carried out, which is known as Curtis stage. Just downstream to that, there are 16 number of reaction stages, and this stage has degree of reaction as 50%. One by one, steam passes through all the stages, and from outlet, steam enters in condenser because condenser is connected at outlet. Now, whenever steam passes through all the stages, its specific volume increases. Means it will require more volume, and we are providing more volume by increasing height of blade in stage in downward direction. So you will observe that as we move towards outlet in stages, blade height keeps on increasing. Again, during operation, regulating or governing of steam turbine is necessary. It means that though there is change in load, speed of turbine should remain constant. And for that purpose, here we have governing mechanism. There are many types of governing mechanisms, governing systems, but our turbine has throttle governing. Means steam enters over here, and at inlet itself, just to maintain the speed, throttling of the steam is carried out. Now, whenever steam turbine operates, due to reduction in pressure in downward direction, axial force always will act on rotor, and we are supposed to nullify that axial force. For that purpose, many design methods are there, but in this turbine there is presence of dummy piston which will nullify or which will reduce axial thrust. In this turbine there is presence of dummy piston, and across the dummy piston pressure difference should prevail. It is provided to nullify axial thrust, and here we can see that there is connection between outlet of steam turbine and one face of dummy piston which is present at inlet. Due to this connection, very low pressure acts on dummy piston, opposing axial thrust is developed, and on the rotor, net axial thrust almost will be zero. This is necessary mechanism. Now, whenever this kind of mechanism is present, thrust bearing will have to take very small value of the load, and that is its advantage. Again, whenever steam turbine operates, power will be generated, and inside this electrical generator, steam turbine operates. It will drive electrical generator. It will run at particular speed, and with the help of dynamometer, swinging field dynamometer, we can measure power which is generated by electrical generator. Now, this power is consumed by suitable mechanism, and whenever we want, during performance testing, we can keep on increasing the load, and different readings can be taken.